Okay, students, today we're going to begin our study of trigonometry. And we're going to study right triangles, angles of elevation, and angles of depression. Today's notes will be in two parts, so make sure you watch both parts. We're going to start our lesson today with some vocabulary. Trigonometry is the word I mentioned first. It is the study of right triangles. When we're studying trigonometry, we really study trigonometric ratios. And trigonometric ratios, it's a ratio which is a comparison of two numbers. So what are we comparing? It's a ratio of the lengths of the sides of a right triangle. Okay. There are three of them that we study: tangent, sine, and cosine. These are the names of the three trigonometric ratios that we are going to be studying. The first one, tangent, because it's a ratio, we're going to write it's the ratio of the lengths of the legs of a right triangle. So here, it's just going to be the two legs that we're going to make a ratio of to make the tangent function. Sine and cosine are not going to be the two legs. It's going to be one of the legs and the hypotenuse. So here, this is going to be the ratio of the lengths of one of the legs and the hypotenuse of a right triangle. Okay, two more. Angle of elevation and angle of depression. Now that's going to be in part two, but we're going to do the vocabulary here so we keep all the vocabulary words together. Angle of depression. Angle of elevation. The angle your line of sight makes with a horizontal line when looking up at an object. Okay. Okay, so here we're looking up at an object. That's why it's elevation. Think like an elevator going up. Angle of depression, it's going to be the same thing, but it's going to be looking down. So the angle your line of sight makes with a horizontal line, excuse me, when looking down at an object. Okay. Here's our first three our three trig functions that we're going to study. Sine. It's pronounced sine, but when you look at it on a calculator or you see it in a book, you're not going to see it written like this. You're going to see it as S-I-N. Now, I know that that is short. That looks like sin, but we do not pronounce it sin. We pronounce it sine. So whenever you see S-I-N, you don't say sin, you say sine. The next one, cosine, we will see C-O-S on our calculator or in our books or in our workbooks. And whenever we see C-O-S, we don't say cos, we say cosine. And this one, T-A-N. When we see tan on our calculator or in our workbooks or textbooks, we don't say tan, we call that tangent. Now, sine is always, always, always going to be the ratio of two sides. And the two sides that it's going to be the opposite. And before we start here, I want to look at this triangle so that you can understand what the word opposite means. So first of all, let's go ahead and take a color and look for our angle. So right here, I see an angle identified with a symbol, and it's a Greek symbol called theta. It's a circle with a slash through it, and that is a Greek letter theta. So in relationship to this angle, what would the opposite side, opposite from that angle? Well, opposite from that angle is going to be this side over here, opposite, across from. Okay? Now, because this is a right triangle, there's one side that never changes, and that side is going to be the hypotenuse. So this one is the hypotenuse. And this side over here that helps make the angle, it's part of this angle, we call that adjacent because it's next to the angle. Okay, so this is going to be opposite. This is adjacent. And this is the hypotenuse. So over here, sine, it's going to be the ratio of two of the sides, and the two sides that it's a ratio of is the opposite over the hypotenuse. And to help us remember that, I want you to think of the letter S for sine, O for opposite, H for hypotenuse. So, S-O-H. That means sine is opposite over hypotenuse. Okay? Next, we have cosine. Cosine is always going to be adjacent over hypotenuse. So to help us remember this one, we're going to use C for cosine, and we're going to put the A and then the H, and that's going to stand for cosine is adjacent over hypotenuse. The next one, tangent. Tangent, remember up here it says the ratio of the lengths of the legs, so it's going to be the two legs, the opposite and adjacent. So here we're going to put opposite, and it will always be the opposite on top and adjacent on bottom. So here we're going to use T for tangent, O for opposite, A for adjacent. TOA. And to help you remember this, SOHCAHTOA, whenever you think of trig functions, I want you to remember SOHCAHTOA. This should help you remember it. Meet SOHCAHTOA. It has absolutely, just because SOHCAHTOA sounded like an Indian name, a friend of mine, Miss Battles, came up with this picture and named this chief SOHCAHTOA. So this meet Chief SOHCAHTOA. So whenever you think of trig functions, I want Chief SOHCAHTOA to pop into your head. All right. So now, what was the very first thing that we highlighted on our triangle before we even got started? What color did I highlight first? If you think in red, then you're thinking correctly. When we apply this to a right triangle, you must look for the angle first. Always identify your angle first. And sometimes we call that angle theta. And that's just the Greek symbol theta. Okay, here's some examples. Okay, so here, I'm going to use my colors, same colors. Okay, so the pink was for the hypotenuse. So here I'm going to color the hypotenuse pink. Hypotenuse pink. And then red was for my angle. So here's my angle here. Here's my angle here. Yellow stood for adjacent. And remember, adjacent has to be next to. It's part of the actual angle. So the adjacent on this one is going to be here, but the adjacent on this one is going to be over here. Okay? Make sure you notice that in between these two examples, the placement of theta changes. These are the same exact triangles, but here we're talking about theta down here, and now we move theta up here. And you'll see that these ratios will change. Okay, now this over here is across from theta, so that's the opposite side. And this would be across from theta, so that's the opposite side. Okay, so now if I'm going to use SOHCAHTOA, remember this is going to be, let's go ahead and put these words adjacent, opposite, and hypotenuse. And I'm going to label this one as well. This one's across from, so that's opposite. This one's hypotenuse because it's across from the right. And this one helps make the angle, so this is adjacent. Okay, so now when I'm looking for sine theta, all I have to do, the sine of theta, sine is opposite over hypotenuse, all I have to do is locate the opposite, which is length A, over the hypotenuse, which is C. And I'm color coding these so you can go back and make sure that you have them right. Okay, cosine. Cosine was adjacent over hypotenuse, so adjacent, that's going to be B over C. So this time it's going to be yellow for me, and I chose pink for hypotenuse, so that's yellow over pink. Okay, and the last one here, tan theta. Tan is opposite over adjacent, so whenever we're trying to find tan theta, it's going to be the opposite length, which is A, over the adjacent, which is B. So that's going to be green for me. I chose green for opposite, and I chose yellow for adjacent. Okay. Alright, so sine is going to be A over C, cosine is B over C, and tangent is A over B. Over here, this is, since we switched the angle, that's why it's so important to locate your angle first. Because we switched the angle, everything's going to be different. So here, sine is always opposite over hypotenuse, but here opposite becomes B over C. So this time it's going to be, for me, I chose green for opposite, so that's going to be green over pink. So notice how I'm still using opposite over hypotenuse, so it's still green over pink, but notice how the letters have changed. This is A over C, and this is B over C, just because we flipped the angle, the acute angle of the right triangle. Okay, now cosine. Cosine is going to be adjacent over hypotenuse, so that's going to be A over C. Alright, so it's still going to be yellow over pink for me, because it's always going to be adjacent over hypotenuse, but notice how the letters have changed. This was B over C, this one's A over C. And then finally, tangent. Tangent's going to always be the two legs, but it's always going to be opposite over adjacent, so that's going to be B over A. And look what happened here. This is still green over yellow, but the letters have flip-flopped. This one was A over B, this one is B over A. So it really does make a difference. You have to pay attention to where the placement of the angle is. All right, page 2. Okay, now you need to get your calculator so you can follow along and punch things into your calculator. Okay, so first of all, because we're dealing with trig, and trig happens to be the study of right triangles, and we've been talking about angles, we measure angles in degrees. There's a certain setting on your calculator that when you're dealing with trig, you have to make sure you change the setting in your calculator, otherwise you're not going to get the right answer. So grab a calculator and find the mode key. The mode key is next to the second key, and then here, if you'll look down 3 columns down, you'll see the word degree. If you arrow down, you're going to see radian flashing. You want to arrow over until it's flashing on top of degree, and then push enter, and that changes the mode. Then hit clear, and your calculator should be a mode. Now, here's how you can determine whether or not your calculator is in degrees. If it's in degrees and you hit tangent of 90, you should get an error message because you can't find the tangent of 90 degrees. Okay, so to test it, let's go back to mode, arrow down to radians, then hit tangent 90 degrees, enter. See how it gives me a negative? If you get a negative, we can't have a negative distance in geometry. So whenever you get that, that's how you test to make sure that your calculator is in the right mode, like if you're taking a quiz or a test. And if you type in tan 90 and you get a negative, you know that you've got to go up here to the mode and change it. So let's go clear it, go to the mode, scroll down, arrow over to degree, enter, and now my calculator's in degrees and I'm set. Okay, so here we are finding the missing sides. Okay, take a look at that. If this was a right triangle and I'm told to find the missing side, can't you just do that using Pythagorean theorem? Well, if you had one more side length, you could, but notice how I have 2 sides missing. That's when you want to use trig. That's the purpose of trig. It's when we know one of the angles, we know this angle or this angle, but 2 of our sides are missing, and that's what we need to find. Okay, so let's go ahead and practice setting up our trig ratios. Okay, but before we get started, I want to make sure that you write this at the top. Set mode 2 degrees. And then here, what are we doing? We're finding the missing side. So find the missing sides. Okay, that's our objective. Okay, so using the same colors as before, I'm going to first of all locate my angle. Here's my angle in question. That's in red. Now, opposite, remember I chose green, so I'm going to stick with the same color. That's opposite. Across from the right angle is the hypotenuse. And that I had in pink. The angle was red. Okay, and then the adjacent was yellow. Okay, so sine of 28. The sine of this one, SOH, remember, SOHCAHTOA, SOHCAHTOA. That's going to help us remember how to set up the ratio. So sine of 28 is going to equal opposite, which is 3, over the hypotenuse, which is C. Cosine 28 is going to be the adjacent, which is B, over the hypotenuse, which is C. And tangent 28 is TOA, opposite and adjacent, opposite 3 over adjacent B. Okay, so if I'm setting up a proportion and I'm trying to find a missing side, there's one ratio there, or one set of proportions there that I cannot use. And it's the one that has two variables in it. Here I have a number and a variable. Here I have two variables. Here I have a number and a variable. This one right here is not useful. This one's not going to do me any good. But I'm going to use this one and this one to find my B and my C. Okay, so step 1. Let's find B. To find B, I'm going to choose this one here with the B. I'm going to put tan 28 over 1 equals 3 over B, and I'm going to cross multiply just like I've always done. So that's going to be tangent 28 B equals 3 times 1, or just 3. Now, I'm going to divide. I want to get B by itself. I want to find out the length of B. So I'm going to divide by tan 28, tangent 28. Okay? So that means that when I punch this into my calculator, 3 divided by tangent 28, then I will know the length of that side. Okay, so let's take a look at our calculator. So here, I'm going to type in 3 divided by, and then tan 28. Tangent 28. It opened up a set of parentheses, so you need to close it. Enter. So that's going to be 5. B is approximately 5.642179396. Whenever we are dealing with trig, we want to round to 4 decimal places. That's the 10,000th place. So I want 4 decimals. 1, 2, 3, 4. So let's round. B is approximately 5.6422, because we round up. All right, let's draw a line. And now let's find C. Okay, so for C, I'm going to use this one. So I'm going to put sine 28 over 1 equals 3 over C, cross multiply. That's going to be sine 28 times C equals 3 times 1 or 3. Divide by sine 28. Divide by sine 28 on both sides. Cancels out over here. So C is going to be 3 divided by sine 28. So that's what I'm going to plug into my calculator. So here, 3 divided by sine 28, close my parentheses, I'm going to get C is approximately, now remember, round to 4 decimal places. That's going to be 6.3902, because that rounds up. Okay, next problem. This one is up here. There's my angle. I always identify this one first. Then this is going to be opposite. This is hypotenuse. This is adjacent. Okay, so it's all the same color scheme. Opposite, hypotenuse, adjacent. Okay, so sine 68 is going to be B over C. Cosine 68 is going to be 3 over C. Tan 68 is going to be 3 over B. Alright, so which one can I not use? It's the one with 2 variables. So I'm not able to use this one. It will not help me. Okay, so let's find B first. Find B. Alright, so here I'm going to put tan 68 over 1 equals 3 over B and cross multiply. Tan 68 times B equals 3 times 1, which is 3. So divide both sides by tangent 68. I get B equals 3 divided by tan 68. Now folks, this right here is considered to be the exact answer. When I plug it into my calculator and I round it, that's my estimated answer. So let's plug this in. That's going to be 3 divided by tan 68, close parentheses, and I get B is approximately 1.2121 because that rounds up. Alright, next, find C. To find C, I'm going to put cosine 68 over 1 equals 3 over C. Cross multiply. I get cosine 68 times C equals 3 times 1, which is 3. Divide both sides by cosine 68. I get C is 3 over cosine 68. There's my exact answer. My estimated answer, of course, is 3 divided by cosine 68, close parentheses, enter, 8.0084. Okay, let's move on to the next one. Now the next one says find tangent B, find tangent T, find sine B, find sine T, find cosine B, find cosine T. Write each answer as a decimal rounded to the nearest thousand. Okay. Alright, so let's list these out. Tan B, tan T, sine B, sine T, cosine B, cosine T. Alright, and the trick here is to make sure that you locate the angle first and then write the correct numbers over each other. So here's B, and when I'm talking about B, this is the opposite, this is the adjacent, this is the hypotenuse. Okay, whenever I have a B. So tangent is going to be opposite over adjacent, so that's going to be 28 over 21. Sine, that's so, remember so katoa, that's going to be opposite over hypotenuse, so that's going to be 28 over 35. Okay, and then cosine is going to be adjacent, which is 21 over hypotenuse, 35. So 21 over 35. Alright, now let's go back and do these. T. So here's my angle here, so that means these are all going to change. Okay, first of all, across from the right angle is hypotenuse, so actually hypotenuse never changes, so I didn't have to erase that one. But if I'm looking at T, the opposite side is now this one. And the adjacent side is now this one. Okay, so tan T is going to be 21 over 28. Sine T is going to be the opposite over hypotenuse, 21 over 35. And cosine T is going to be 28 over 35. Okay, now it says, write each answer as a decimal rounded to the nearest thousand. All you do is plug in these here, 28 divided by 21, and round to the nearest 10,000. So that's going to be 1.3333. 21 divided by 28 is going to be equals 0.75. Now, that one we don't round to the 10,000s because it terminates. So that's an exact answer. So we can put the equal sign. 28 divided by 35 is 0.8. 21 divided by 35 is going to be 0.6. 21 divided by 35, we already did that one. That's going to be 0.6. 28 divided by 35, we already did that one up here. That's going to equal 0.8. And we found them all. Okay, next. You're going to have one like this on your homework. And it says, find the value of x to the nearest 10,000. We're looking for the missing side. Sure wish I could use Pythagorean theorem, but I can't. This angle right here you may not be able to read, but it is 50. 50 degrees. Okay, so locating my angle first. Here's my angle in red. Then that makes this the opposite side. That makes this the hypotenuse. And that makes this the adjacent side. Look and see what you have. I have information here in green, the opposite, and I have information here in yellow. Opposite is given and adjacent. Which trig function allows you to use both the opposite and the adjacent? TOA. Trig function is tan. So what we want to do is set up a proportion. Tan 50 over 1 is going to equal 44 over x, and then we cross multiply. So that's going to be tan 50 times x equals 44 times 1 of 44. Divide by tan 50. Divide by tan 50. My x is going to be 44 divided by tangent 50. Now, that's my exact answer, but I want to take that and I'm going to plug it into my calculator. 44 divided by tan 50 gives me approximately 36.9204, because that 8 makes that 3 round up. Okay, so there's my estimated answer and my exact answer. Alright, Last page of examples. Okay, the last page of examples I have says use a tangent ratio. So I already know what to use. And this is 40 degrees. Okay, so tangent is going to be opposite over adjacent, TOA. So I put tan 40 over 1 equals opposite, which is 13 over x, and I cross multiply. So tan 40 times x equals 13 times 1, or 13. Divide by tan 40, divide by tan 40. X is going to equal 13 divided by tan 40. Now remember, this right here is my exact answer, and they want me to round my answer to the nearest 10,000. So that's going to be approximately, I'm going to plug that into my calculator, 13 divided by tan 40, close my parentheses, I get 15.4928. Alright, so there's my answer for number 7. Okay, look at this one. This one says find the area of the triangle. And looky there, we've seen that one before. We've already found x. X is 13 divided by tan 40, or 15.4928. But when we're trying to find the area, we want to make sure we use the exact answer, not the rounded answer. We only want to round at the very end of the problem. So, from example 7, we know x is equal to 13 divided by tan 40. And that is my exact answer. And also write down so you can have this on your homework when you're trying to do your homework. Do not use the rounded answer. Okay, you don't want to use a rounded answer. You want to use exact and only round at the very end. Okay, remember, area of a triangle is equal to base times height divided by 2. So my base, which is 13, so that's going to be 13 times my height, which is going to be 13 tangent 40 divided by 2. Okay, so plug that into the calculator. And that gets a little tricky, but plug it in just like you see it. We're going to plug in 13 times, and then here we're going to put this in parentheses. That's going to be parentheses 13 divided by tan 40. Now notice how you have two brackets open. When you have two brackets open, you have to close it twice. So close, close. Now hit enter. But that's not your answer because you forgot to divide by 2. So now we divide. We don't enter that number in again. You just hit the division key, and notice how it puts ANS. It's taking the answer and loading it here and dividing that answer by 2. So that's going to be approximately 100.7032 is my answer. That's my area. Okay, the next one. Notice how we have this same exact triangle. This time we're going to find the perimeter. Well, we already have this one. This one over here is going to be tan 40. 13 divided by tan 40, because we know that from above. Well, how can we find this third side? Because we want the most exact answer that we can have. So this is my hypotenuse. Well, I have 40, I have this one, and this is what I want over here. I'm going to find y, because my perimeter is going to equal x plus y plus 13. To find y, that's going to be opposite over hypotenuse, so that's going to be sine. So sine 40 over 1 is going to be 13 over y, cross multiply. You get sine 40 times y equals 13. Divide by sine 40. Y equals 13 sine 40. 13 divided by sine 40. Okay, so that's what you want to plug in here. Okay, when I plug this into my calculator, I'm going to use parentheses. So parentheses 13 divided by tangent 40, remember to close, plus 13, oops, parentheses, forgot, 13 divided by sine 40, close, plus, don't forget the base, 13. When you type that in, you're going to get perimeter is equal to 48.7172. And we should use the approximate because we've rounded. So perimeter is approximately 48.7172 units. This was units because they didn't give us one. This one up here should be units squared because they didn't give us a unit. Alright, last one. Use cosine or sine ratio to find the value of each variable. Round your answers to the nearest 10,000. Okay, so here's my angle right here. I'm going to find u first. Sine 39, I chose sine because that's opposite over hypotenuse. This is opposite, hypotenuse. This is adjacent. Okay, so sine 39 is going to be u over 32. Cross multiply. Now this time you're going to have u equals 32 times sine 39. So plug that in just like you see it. 32 sine 39, close parentheses, enter, and you should get 20. U is approximately 20.1383. Alright, the next one, T. T is going to be adjacent and hypotenuse that we're going to use. So that's going to be cosine. Cosine 39 over 1 is going to be adjacent, which is T, over 32. Cross multiply. I get T equals 32 cosine 39. Alright, so plug that into your calculator. So T is approximately 32 cosine 39, close parentheses, and you get approximately 24.8687. And we are done. And that's the kind of homework that you're going to have. Okay, don't forget about part 2.